Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें प्लेन डिफ्रैक्शन ग्रेटिंग ए विषय रे पढिबा ऑलरेडी हमें diffraction at multiple slits or n number of slits विषय रे पढ़ी सारछु okay so plane diffraction grating कहले actually it is an arrangement which is consisting of a large number of slits such that the slits are having equal width and they are separated by equal opaque portions okay that means the distance between two consecutive slits in this arrangement is maintained to be constant okay so such an arrangement is called as your diffraction grating okay so केवल प्लेन डिफ्रैक्शन ग्रेटिंग बोली नहीं कन्वेक्स ग्रेटिंग अच्छी कनकेव ग्रेटिंग मध्य अच्छी से जहाँ भी हो so the grating is actually constructed by ruling equidistant parallel lines with a fine diamond point on a optically plane glass plate okay such that it will form a plane diffraction grating so आमे कौन करिबा याकू जदि आमे देखिबा यार कंस्ट्रक्शन एक्चुअली गोटे डायमंड निया जाए ओके डायमंड रो ए जो तळे ए फाइन टिप अछि okay this tip is used to rule lines on a glass plate okay it is done by sophisticated instruments okay and the lines are ruled in such a way that the opaque portions are the lines okay the ruled lines are the opaque portions while the space between two consecutive lines is acting to be the transparent portion to the light okay and this grating is used in the laboratory generally तमे optics रो practical भी करथबो जो थरे कि तमे sodium light रो wavelength okay spectrometer नै की करूछो by using plane diffraction grating so generally it has 15,000 lines per inch माने गोटे इंच that is 2.54 सेंटीमीटर ए पाखा पाखी सो एते की कम डिस्टेंस रे 15,000 लाइन्स अछि ओके सो खाली आखि रे जदि हमें देखिबा then the grating will look like a simple glass plate आमे जानि परिबा नहीं okay and one more thing जो practical रे आमे यूज करछु grating that is actually the replica okay not the original one original grating को कोन करा जाय गोटे ट्रांसपेरेंट लिक्विड उपरे तार छापटा पके दिया जाए एंड से लिक्विडटा पुनी ठंडा हो गला सो दैट वी आर गेटिंग द रेप्लिका और द डुप्लीकेट ओके सो जोटा तमे प्रैक्टिकल रे यूज करूचो प्लेन डिफ्रैक्शन ग्रेटिंग दैट इज द रेप्लिका नॉट द ओरिजिनल वन बिकॉज ओरिजिनल टा बहुत कॉस्टली ही था ओके सो दिस इज ऑल अबाउट द प्लेन डिफ्रैक्शन ग्रेटिंग यार कंस्ट्रक्शन हमें देखिला एबे यार थ्योरीटा देखिबा ओके so for this let us go directly to the figure okay so its theory is very much similar to the diffraction which is produced due to the multi slits or n number of slits okay so here we have considered a grating which is xy okay this one right and let us say that this is a plane diffraction grating or याको हमें plane transmission grating मध्य कहि थाउ okay now we have placed a screen here S okay and both are perpendicular to the plane of paper right now the slits are parallel and perpendicular to the plane of paper okay you can see a jo transparent portion achi these are the slits right and let us say that width of each slit is taken to be small a okay गोटे छोटो जो distance रहुची एठी गोटे width रो thickness टा जोटा that is taken to be small a and the width between two consecutive slits, that is nothing but the width of the opaque portion. This one is taken to be suppose small b, right? ताले आमे एठी a plus b को लिखि परिबा as the grating element. Okay, grating element याको कहा जाए, right? Now suppose we consider a parallel beam of light. Okay, this is shown by the arrow mark. Suppose it is having a wavelength lambda. Okay, it is incident normally on this grating, or in other words, a plane wavefront be incident on this grating. Okay, now as the width of the slit is comparable with this wavelength lambda of light, because एठी width बहुत ही छोटा रहिबो. Okay, जेमति हम ऊपर देखिला 15,000 lines are there in 1 inch, so the width will be very much small and it is comparable to this wavelength lambda, right? Now ये जो comparable रहिगला wavelength सहित, so that we will have, as per Huygens principle, each point on the slits will send out the secondary wavelets in all directions, right? And all these secondary waves which are traveling in the same direction as that of the incident light will come to focus on the screen at this point O, right? So মানে দেখো, after passing through this convex or converging lens, they will be focused at this point O on the screen. Okay, and all these secondary waves will cover equal path. Okay, so that there will be no path difference between them. Hence this point O will be a bright spot, right? Because they will reinforce with each other in phase. Okay, so the point O will be a central bright maximum, and this is called as central principal maximum. Okay, so let us see or analyze the principal maximum. Okay, so secondary wavelets which are there and diffracted suppose through an angle theta, right, with the direction of incident light. Okay, and this is what shown in the figure 6.19. Okay, so ଏବେ ଦେଖ ଆମେ ଏବେ ଗୋଟେ direction ନେଲା, okay, which is at an angle theta with the incident direction, right? Now the collecting lens here, you can see এটা ଏବେ vertical न ହେଇକି it is tilted. Okay, so it is rotated such that the axis of the lens is parallel to the direction of the secondary waves. Okay, and these secondary waves will come to focus on the screen at the point here at P, right? Okay, they will be coming to focus at this point P, right? Now এইଭଳିଆ ଆମେ ସିଚୁଏସନ୍ ଦେଖିଥିଲା ସିଙ୍ଗଲ ସ୍ଲିଟ୍ରେ, ଡବଲ ସ୍ଲିଟ୍ରେ ଆଉ ମଲ୍ଟି ସ୍ଲିଟ୍ସରେ ମଧ୍ୟ. So here also there will be a path difference between the secondary waves starting from the point A and C. Okay, ଯଦି ଆମେ ଉପରୁ ଫାଷ୍ଟ ସ୍ଲିଟ୍ଟାକୁ ଦେଖିବା ट्रांसपेरेंट आउ ओपेक पोर्शन, सो ए बी ହେଇଗଲା ट्रांसपेरेंट पोर्शन, बी सी ହେଇଗଲା ओपेक पोर्शन. सो ए आउ सी एटा आसिला जो दुईटा पॉइंट. ओके, एई दुई पॉइंट रु जो लाइन गुडा जाउची सेमानक भितरे आमे जदि पाथ डिफरेंस देखिबा देन इट विल बी इक्वल टू सी के. ओके, एठी बहुत छोटो छोटो एटा दिया हिची. ओके, सी के विल बी पाथ डिफरेंस and this will be nothing but equal to AC sin theta, and here AC means A plus B, that is the grating element, right? So CK equal to A plus B sin theta. Okay, now accordingly in this point P eta maximum haba intensity ketebele if this path difference will be an integral multiple of the wavelength lambda. ओके, एटा ऑलरेडी हमें डिस्कस कर सारिछु. सो हमें लिखि परिबा एबे. ओके, यार इक्वेशन को एबे डायरेक्ट जिबा. ओके, सो वी कैन राइट हियर that a plus b sin theta जोटा कहली एठी path difference टा. So this will be an integral multiple of lambda. Okay, here it is written a plus b sin theta equal to n lambda, where the value of n is equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. Okay, and remember we have taken n is equal to 0, which is corresponding to the central principal maxima, that is at the point O. Okay, and the other values, that is n equal to 1 2 3 plus or minus mane left side or right side re they will correspond to different order of the maxima, okay, which are called as the principal maxima on either side of this point O. Okay, so for n equal to 1, suppose ame jodi consider kala, then a plus b sin theta 1 equal to lambda. Okay, and this will give you the condition and direction, that is theta 1, for the first order principal maximum, which is produced on either side of the central maximum, that is at the point O. Okay, now here intensity, obviously it will be less than that of the central maximum. Remember, central maximum re hi सबुठु highest intensity रहिबो. ओके, तापरे आमे जेते ताठु दूरकु जिबा लेफ्ट और राइट रे इंटेंसिटी कमी कमी जिवो. ऑलरेडी तमे देखिछो इंटेंसिटी डिस्ट्रीब्यूशन कर्व. ओके, नाउ अगेन फॉर द केस n equal to 2, we will have a plus b sin theta 2 equal to 2 lambda. Okay, so this will give you the condition and direction theta 2 of the second order principal maximum, whose intensity will be now less than that of the first order principal maximum. Okay, so in general the direction theta n for the nth principal maximum will be a plus b sin theta n equal to n lambda. Okay, this is the general condition. Okay, so ये है principal maximum. Now let us go to the secondary minima and maxima. Okay, so जो हमें direction देखिला theta n, which is corresponding to the nth principal maximum, is given by this relation a plus b sin theta n equal to n lambda. Now, if the angle of diffraction is increased, let us say by a very small amount, suppose d theta, then the path difference between the secondary waves, again ऊपर जो figure टा देखिला, from the points A and C will be now increased by a factor lambda by n. Okay, here capital N will be what? It is the total number of lines on the grating. Okay, then the path difference between the secondary waves coming from the extreme ends of the grating will be changed. Okay, it will be now lambda by n into n. Okay, that is equal to lambda. Okay, now the grating can be assumed to be divided into two equal parts. Okay, याको हमें दुईटा समान भागरे भाग करि परिबा. Okay, therefore the path difference between the secondary waves from the corresponding points of two halves will be lambda by 2. Okay, जदि दुई भाग कला हमें total path difference होतला lambda, एबे जेतु we have divided into two parts, so एबे path difference for each part will be lambda by 2. Hence these waves interfere destructively, okay, that is out of phase and in this direction. Okay, so that they will cancel each other's effect, thereby you will get a dark spot. Okay, thus the condition theta n plus or minus d theta, okay, जो हमें increment कला by a very small amount, will give you the direction for the first secondary minimum after the nth principal maximum, right? अच्छा, आकु बढ़िबा. Now the direction of the secondary waves, again from the point A and C, be such that the path difference between the secondary waves from these two points, let us say that, be increased by 2 lambda by n. Okay, या पूर्वरु देखला lambda by n. Now let us say that it is increased by 2 lambda by n. Then the path difference between the secondary waves from the extreme ends, पूर्व भली से भले हबो 2 lambda by n into n, that is equal to 2 lambda. Okay, ताहले एबे हमें ग्रेटिंग को चारि भाग रे 4 equal parts we can divide it. Okay, then the path difference between the secondary waves from the corresponding points from the upper two parts, remember upare thiba duita part, okay, and the lower two parts, okay, will be how much? Again lambda by 2. Hence again destructive interference will takes place. Okay, and we'll get the second secondary minima on either side of the nth principal maxima. And similarly path difference जदि हमें secondary waves रो नहीं जिबा, again 3 lambda by n, 4 lambda by n and so on up to केते जिबो n minus 1 lambda by n. Okay, remember capital N thila number of lines drawn or ruled in the grating. Okay, accordingly we will get the third, fourth and so on etc. order of the secondary minima. Okay, acha, thus we can see here that there will be n minus 1 secondary minima between two consecutive principal maxima. Okay, এই কেসটা আমি প্রিভিয়াস ক্লাসে भी দেখিଥିଲା at the end. Okay, hence there will be যদি এটি n minus 1 secondary minima ଅଛି তাহলে দুইটা মিনিমা ভিতরে নিশ্চয়ই গোটে ম্যাক্সিমা রহিব that is called as secondary maxima. Okay, so যদি n minus 1 secondary minima ଅଛି then there must be n minus 2 secondary maxima between two principal maxima. Okay, so the intensity distribution curve on the screen is shown here in this figure. Okay, so it is the figure re, this is the central principal maximum having the highest intensity. Okay, tapore এটি আসুচি ফার্স্ট অর্ডর প্রিন্সিপাল ম্যাক্সিমম. ওকে, ইন্টেন্ସିଟି ଦେଖ କମ୍ପାରେଟିଭଲି କମିଯାଇଛି. ତାପରେ ସେକେଣ୍ଡ ଅର୍ଡର ପ୍ରିନ୍ସିପାଲ ମ୍ୟାକ୍ସିମମ୍. ଓକେ, ଆଗକୁ ବି ଅଛି. ସୋ ଏଠି ଆମେ ଯଦି ଦେଖିବା ফার্স্ট অর্ডর আউ সেন্ট্রাল ইয়া ভিতরে যদি মিনিমা আমি কাউন্ট করিবা 1 2 3 4. ওকে, সো n minus 1 equal to 4, that means এটি আমি n equal to suppose 5 নিচু. ওকে, যদিও it is a very small quantity, actually n ର value ବହୁତ large ହେଇଥାଏ. ওকে, suppose ଆମେ n equal to এটি 5 নিচু তাহলে দেখো number of secondary maxima এটি কেতে ହେବ এটি 1 2 3. Okay, that is n minus 2, right? So এই কেসটা আমি previous class রে भी discussion করছিলা for the diffraction which is produced at the multiple slits or n number of slits. Okay, now let us go further. Now let us see the width of principal maxima. Okay, this is very important, এটা question भी আসে principal maxima ର width बाहर କରିବାକୁ question ଆସିଥାଏ. तो देखो ऊपर जो आमे equation 6.43 पाइला for the direction of nth order principal maximum, it was given by equation that is a plus b sin theta n equal to n lambda. Okay, so याकू जदि आमे figure रे बुझिबा, suppose ए जो मझिरे लाइन टा देखुचो, okay, this is the line corresponding to the angle theta n, right? So at this position we are getting the nth order principal maximum, right, at this point theta n. Now आमे एठी small increment or decrement करिबा ए theta n रो by a value or a very small quantity d theta. Okay, so एठी ऊपरे आउ तळे आमे d theta रो increment or decrement करिबा so that we are getting theta n plus d theta and theta n minus d theta, which will be corresponding to the direction of first secondary minima on either side of this nth order principal maximum. Okay, so एठी देखो गोटे first minima आसिला, एठी भी first minima आसिला secondary minima. Okay, both side रे. So equation जो ऊपर थिला एबे एटा चेंज हे गला a plus b sin theta n plus or minus d theta equal to n lambda plus or minus lambda by n. This is the equation for the first secondary minima. एबे ये दुई equation जो पाइला याकू एबे हमें divide कर दबा. Okay, now after division, okay, याकू एबे solve करिबा जदि, okay, sin a plus b रो formula पकेला. Okay, ताले एठी देखो ये जो cos d theta अछि आउ sin d theta अछि, since the value of d theta is very small, so we can take here cos d theta to be nearly equal to 1 and sin d theta to be nearly equal to d theta. Okay, याकू replace कर देला ये numerator रे, याकू पुणी solve करी करी गला. Okay, so at the end we are getting what, the value of d theta coming out to be 1 by small n capital N cot theta n. Okay, so a जो value d theta will refer to the half angular width. Okay, এটা width হবনি width. Okay, width হব of the nth principal maximum. Okay, so याकू जदि आमे figure रे देखिबा ताले देखो, coming back to the figure, nth order principal maximum टा एठी थिला. Okay, पूरा total width और full width हे गला केते ना 2d theta. Okay, आ half width माने एति की हे जिवो तमरो d theta. Okay, एटा होची angular width, remember. ओके सो ये जो एंगुलर विड्थ डी थीटा रो वैल्यूटा पाइल सो ये इक्वेशन रु जना पड़ुछि जे इट इज नंबर 1 inversely proportional to capital N, that is the total number of lines on the grating, and number 2 again inversely proportional to n cot theta n, that is the value of n cot theta n is more for higher orders, right? acha ebe dekhiba the orders which are actually absent in case of the spectra with the diffraction grating. Okay, keteta absent order bi rahibo. Okay, so sometime we find that for normal incidence and certain value of diffracting angle, that is theta n, which is satisfying the equation 6.43 jota upare ame dekhila a plus b sin theta n equal to n lambda for the nth order principal maximum, but no maximum is seen in this case. Okay, so actually equation satisfy କରୁଛି କିନ୍ତୁ maximum କିଛି ବି ସେଥିରେ हमको देखा जाऊ नहीं. Okay, it is same as missing spectra or absent spectra in case of your double slits or n slits. Okay, जोटा हमें previous class रे भी देखिथिला. Okay, so काहेकि एमती होउची, let us study its cause, यार कारणटा एबे हमें खोजिबा. ओके सो देखो जो कंडीशन थिला nth ऑर्डर प्रिंसिपल मैक्सिमम पाई, दिस वन also the condition for suppose mth order minimum, okay, in case of a slit. Okay, so slit कहले हमें एठी बुझिबा the transparent part of the grating. Okay, so transparent part रो हमें width केते नहीं small a, so it is given by small a sin theta n equal to m lambda. Okay, so when both these conditions are simultaneously satisfied for the certain value or certain direction of theta n, তাহলে কোন হবো the resultant intensity at the particular order, this particular order will be 0. Okay, that is that order of the spectra will be absent. Okay, କାହିଁକି ଏମିତି ହେଉଛି, this is because although the diffracted rays from all the transparencies of the grating reinforce with each other, but those from each transparency will mutually cancel the another's effect. Okay, बाकी जिते सबू diffraction होउची निजे निज सहित से माने कैंसिल कर देबे तांकर इफेक्ट टाकू. ओके, सो दैट रिजल्टेंट इंटेंसिटी केते आसी जिवो, सिंपली 0 हे जिवो, एंड इट विल गिव यू द एब्सेंट स्पेक्ट्रा, राइट? सो देखो ए इक्वेशन जो दुईटा हमें पाइला, अगेन याकू हमें डिवाइड करिबा. ओके, डिवाइड करी कि जदी सॉल्व करि जिबा, देन वी आर गेटिंग b by a equal to n by m minus 1. That means for the absence of a particular order, suppose nth order jodi absent achi, then it depends upon the relative values of a and b, mane width of transparent and opaque portions. Okay, याको एबे एग्जांपल ले बुझिबा. suppose हमें नै गला a equal to 2b, ताले n by m रो वैल्यू ए जो ऊपर इक्वेशन टा पाइला, its value is coming out to be 3. okay, ताले ये जो n by m equal to 3 आसिला, that means n equal to 3m. okay, अच्छा एठी m रो वैल्यू 1 2 3 and so on अछि. so missing orders ए स्पेक्ट्रम रे हे जिवो केते ना ए जो n equal to 3m माने 3 6 9 and so on. okay, similarly if a is equal to b, ताले n by m equal to 2, so that n equal to 2m, ଆଉ m ର value 1 2 3 4 पकई देले हमें absent spectra पाइगला for the value of n equal to 2 4 6 and so on. okay, suppose हमें b is equal to 0 नहीं गला, ताले n by m रो value हे गला equal to 1 और n is equal to m, माने एठी missing order केते हे गला, n equal to 1 2 3 4 and so on etc. that means the spectra of all the orders will be missing. okay, so we get the diffraction pattern similar to that of a single slit. okay, किछि भी आउ order रो पाइबा नाही, केवल diffraction pattern टा पाइबा due to the single slit which is corresponding to n equal to 0, right? अच्छा, तापरे एबे आकु बढ़िबा हाईएस्ट ऑर्डर ऑफ प्रिंसिपल मैक्सिमा देखिबा. ओके, सो जो कंडीशन हमें पाइथिला फॉर द प्रिंसिपल मैक्सिमा इक्वेशन 6.43. ओके, सेथरु हमें देखिला जे a plus b sin theta equal to n lambda, or a plus b sin theta n equal to n lambda. Okay, where n is the order of the principal maximum. A plus b jemti कहले it is the grating element, theta ହେଇଗଲା the direction or the angle of diffraction, right? ताले equation जो हमें ऊपरे पाइथिला 6.49. okay, so এই ইকুয়েশন কু আমি লিখি পারিবা বা এই যে ইকুয়েশনটা বি ଅଛି ইয়াকু আমি লিখি পারিবা n equal to a plus b sin theta divided by lambda. Now since the maximum value of the angle of diffraction, okay, जो angle of diffraction माने लाइट टा बेंड जो होची maximum केते एंगल पर्यंत बेंड ही पारिबो 90 डिग्री, theta must be equal to 90 degree its maximum value. Therefore the maximum possible order जदि बाहर करिबा ताले n maximum equal to a plus b sin 90 by lambda. sin 90 1 ही गला, so a plus b by lambda. That means the highest order of principal maxima in the visible spectrum जदि हमें देखिबा with light of wavelength lambda may be evaluated by using this equation. Okay, suppose a plus b is less than 2 lambda. That means याकू जदि हमें put करूचु then n maximum will be less than 2 lambda by lambda or less than 2. जेहेतु n रो वैल्यू होची इंटीग्रल वैल्यू ताले less than 2 हैला माने n रो वैल्यू आसिला 0 आउ 1. okay, that means we are getting the central maximum तो obviously आसिबो. Besides that we'll get only the first order principal maximum. Similarly if a plus b is less than 3 lambda then we'll get n maximum less than 3, or we are getting the first and second order principal maximum. So as per this condition this will give you the highest order of the principal maximum. okay, तापरे आकु बढ़िबा oblique incidence. okay, oblique incidence माने देखो we have considered here in this figure, suppose गोटे parallel beam आछी, okay, monochromatic light. एबे ये जो parallel beam टा suppose normally incident no है कि it is suppose incident obliquely on the grating. okay, suppose it is small I ही गला. okay, this angle is the angle of incidence. okay, गोटे जिनस में भी तुमको confusing लगी पारे जे generally तमे जदि angle of incidence बाहर करो लाइट जदि एपटो आछी ताले এইটা হি थाए नॉर्मल आ ए एंगल टाकू तमे एंगल ऑफ इंसिडेंस नियो, किंतु এই কেসটা কেতেবেলে আসিব যদি এই যে ডটেড লাইন দেখুছ এটা হোথুব যদি सरफेस বা স্লিটস, কিন্তু এটি কেসটা উল্টা আছে. ওকে, सरफेस বা স্লিটস হচ্ছে এই লাইনটা. ওকে, তেণু লাইট এই পটু আসিলা. ওকে, এই सरफेस को नॉर्मलटा हैला এই যে ডটেড লাইন, তেণু করি দিস एंगल विल बी एंगल ऑफ इंसिडेंस दैट इज स्मॉल आई, राइट. अच्छा, तापरे एठी थीटा ही गला सपोज एंगल ऑफ डिफ्रैक्शन, and remember I is not equal to theta, right? Theta होची angle of diffraction. Then the path difference between the secondary waves starting from the corresponding points जदि आमे नबा point A आउ point C. okay, एबे path difference आमे जदि एठी बाहर करिबा देखो एठी angle जदि देखिबा आमे CAL. okay, this angle will be how much? again small I. okay, यार वैल्यू मध्य स्मॉल आई हेबो. केमती हला? बिकॉज देखो एई जो एंगलटा हला 90 डिग्री. ओके, अच्छा, एई एंगलटा होची आई, दैट मीन्स एई एंगलटा हेबो 90 माइनस आई. अच्छा, तापरे एई 90 माइनस आई जो हला एंगलटा अगेन देखो एई एंगलटा, ओके, दिस एंगल इज 90 डिग्री, दैट मीन्स दिस एंगल मस्ट बी इक्वल टू आई. okay, very simple. So angle CAL, okay, this angle is equal to I. Similarly angle CAM, this angle will be equal to theta. okay, now AB plus BC माने width of transparent and opaque portion, that is the grating element, this is equal to small a plus b. okay, then we can write here CL plus CM because path difference टा एटा हबो ए जो CL आउ CM total path difference टा. okay, this is equal to a plus b sin I plus a plus b sin theta. okay, or a plus b sin I plus sin theta. okay, this is the path difference. Now this equation will hold if the beam is diffracted upward as shown in the figure. Okay, जदि ऊपर आड़ को diffraction ହେଇଛି. Okay, so the condition for nth principal maximum जोटा हमें पाउथिला in terms of path difference, that is a plus b sin theta n थिला सेटा एबे याकू हमें रिप्लेस कर देला sin I plus sin theta n. Okay, which is equal to n lambda. Okay, एटा nth order principal maximum पाई replacement आसिला. ताले एबे याकू आम लिखिपर ए प्लस बी देख ये sin a प्लस sin b यही फर्मूलाटा यूज करवा ट्रिग्नोमेट्री. ओके, सो अकॉर्डिंगली वी आर गेटिंग 2 sin theta n plus I by 2 into cos theta n minus I by 2 which is equal to n lambda. याकू एबे सॉल्व करी जिबा. ओके, सो एबे देख sin theta n plus I by 2 रो वैल्यू आमे पाइला this much. Now the deviation of the diffracted beam will be how much? This will be obviously I plus theta n. Okay, याकू फिगर जदि आमे बुझिबा ताले देखो जो डेविएशन टा होची इंसिडेंट डायरेक्शन टा ए पटे थिला. ओके, सो ए पटे हमरो इंसिडेंट डायरेक्शन आसिला किंतु बीम टा ए पटे डिफ्रैक्शन हिची तेणु करी this angle is theta, this angle is I, so I plus theta or nth principal maximum by I plus theta n will be the angle of deviation. Okay, प्रिज्म रे जंती तमे angle of deviation बाहर करो ताले from the above equation 6.57 for the deviation of angle theta n plus I to be minimum we must have sin theta n plus I by 2 minimum. Okay, this must be minimum. Okay, and this is possible only if cos theta n minus I by 2 is maximum, right? ताले maximum value cos theta रही था आमे जानी छो it is 1 तेणु करी theta n minus I by 2 must be equal to 0. cos 0 equal to 1 हुए जेतु, so theta n minus I equal to 0 और theta n must be equal to I. So आमे जो प्रथम स्टार्टिंग रू नहीं थिला जे suppose I is not equal to theta किंतु ए केस पई okay maximum पई आसिला I must be equal to theta n. Hence for minimum deviation we are required to obtain the well defined diffracted image and the incident and diffracted beams must be equally inclined to the grating surface, right? Okay, this is a very important line, right? Now if delta m be the angle of minimum deviation, okay, ताले delta m रो वैल्यू को हमें लिखि परिबा theta n plus I. okay, जेतु हमें पाइला theta n equal to I ताले simply delta m equal to 2I or I equal to delta m by 2 or delta m equal to 2 theta n equal to delta m by 2. So याकू ऊपरे equation 6.56 रे जदि पुट करूछु 2a plus b sin delta m by 2 equal to n lambda. Okay, so when the grating is used in this manner, that is for the minimum deviation condition, that is delta m, then a जो equation हमें पाउछु it refers to the principal maximum for the nth order having wavelength, that is lambda, right? Now at the end गोटे जिनस मन रख जे plane diffraction grating its theory is very much similar to the diffraction at multiple slits or n number of slits. So maybe long question asipare derive the condition for the central maximum, secondary minima and secondary maxima in case of a grating. माने जो previous class रे हमें diffraction at multiple slits रे यारो derivation गुड़ा करिछु. ओके, सेही जिनस को लिखिबा को पड़िबो. Besides that हमें आज जो देखिला width of principal maxima, then absent order, highest order of principal maxima or oblique incidence यारो भी short question आसीबार बहुत chance रही था. Okay, so this is all about your plane diffraction grating. Thank you.